In exercise 8.4, we take a look at solving quadratic equations graphically. Now, just before we begin, there's some important facts about quadratic equations. You may get 0, 1, or 2 x-intercepts, which is essentially what we're doing with the quadratic formula when we're factorizing quadratic equations throughout chapter 7 and also in 8.3 where we learn about the quadratic formula. Now, you may get 0 or 1 y-intercepts, and you will always get a turning point. So these are the three features of a quadratic graph, of a quadratic equation that you're always going to see. Okay, the turning point meaning the point where the graph turns from a negative gradient into a positive gradient, or vice versa if it's upside down. Let's take a look at an example to see where these things feature on a graph. So example 1. Determine the solutions of each of the following quadratic equations by inspecting their corresponding graphs. Give answers to one decimal place where appropriate. So here we've got x squared plus x, take away 2 equals 0, and they're giving us a graph like so, which represents the quadratic equation above. Now, let's see the features. So previously we learnt about finding the x-intercepts using factorizing and also the quadratic formula. Here we can see it visually. So we can see there's 2 x-intercepts. So the first feature is x-intercepts. We have at 2 and 0. So if we were to plug in the quadratic equation to this the quadratic formula to this quadratic equation, we would get x equals to 2 or x equals to 1, okay, as seen above. Alternatively, we could have just used straightforward basic factorization to figure out this one, because we know the factors of -2, which add to 1. Okay, there's an imaginary 1 in front of the x. If you've forgotten what that means, go back to chapter 7 to review your factorizing. We've also got y-intercept. We've just got the 1 y-intercept. Okay, the y-intercept is the point where the quadratic equation hits the y-axis, which is looking at -2. So the coordinate there is 0, -2. And then lastly, I got to draw that a little bit smaller. Sorry, guys, because that kind of overlaps with the turning point. Okay, and then lastly, we've got the turning point, which we'll do in green. So the turning point is where the gradient changes from a negative. So we've got a negative gradient all the way down to no gradient, and then it turns back into a positive gradient. So the third part is turning point, which is what we call TP. That looks to be at approximately, so this just has to be approximate, -0.5 on the x, because it's going down there as -0.5, we can see here. And then that looks to be about like, so 2.5, maybe like 2.2, -2.2 on the y plane. So those are the three features that you have to look out for in each and every graph. Over here, we've got our x-intercepts as decimals. So look, it's just going to be a rough estimate. Realistically, in methods, you'll never have to do anything like this. This would be too easy. So, but just to show you guys what the x and y intercepts are and what we're finding with the quadratic formula is the x intercepts essentially. So here we've got the coordinate. So we've got plurals because we've got 2 intercepts. Let's say that's on the x -0.9 because it's not quite at 1. And the y coordinate will always be 0 on the x axis. And over here we've got like, let's call that 2.9. All right, might be a couple of decimal places off, but for the sake of argument, that's what we're going to go with. We do have a y-intercept that looks to be hitting 5. So we can say y-intercept, could be wrong here. It could be like 4.9 negative, but let's just say it's 5. Okay, remember the x value is always 0 on the y-axis. And then lastly, the turning point. That looks to be on 1 and -5, well, -6.9. Okay, so turning point TP, 1 and -6.9. So we will take a look at how we find all these algebraically, which is what we need to do to sketch a quadratic equation. So the first thing is you always need to figure out x, y, and the turning points, so the x-axis, so the x-intercepts, y-intercepts, and the turning points, and then from there you can sketch your quadratic equation on a graph eventually with the algebra skills that we soon learn. So example 2, confirm by substitution the solutions obtained in worked example 1 are true. So just to confirm, what you need to do is we need to substitute x equals 1 and then x equals -2, okay, into the original equation. So therefore, we have 1 squared plus 1 take away 2 equals 0. Now, if the left side equals the right side after we substituted the 1 into the x, okay, so see how we've replaced the x squared with 1 squared and the x with 1. If the left side equals the right side, it's the right answer, basically. Here we've got, well, 1 plus 1 squared is 1. So 1 plus 1 is 2. Does 2 take away 2 equals 0? Yes, it does. So therefore, true. Over here, instead of having x squared, we're going to have -2 squared. Take away -2. Take 2 equals to 0. So we've that's not right, is it? So we've got a x squared, which we've replaced with -2. That's correct. We've got a positive x, but because we've got a -2 that we're subbing in, it's just actually a negative, isn't it? Correct. So -2 times -2 gets us 4. Take 2, take 2, 4, take 2, take 2. Does that equal 0? Yes, it does. So therefore, it's true. And we've confirmed that our x intercepts are at 1, 0 and -2 and 0. Okay, so that's what example 2 was just asking for us to confirm the solutions above. Example 3, interpreting a worded problem. So a golf ball hit along a fairway follows the path shown in the following graph. The height h meters after it has traveled x meters horizontally follows the rule h equals 1 on 270 brackets, well, times brackets x squared, take away 180 times x. Use a graph to find how far the ball has landed from the golfer. So the ball took a starting point at 0. It reached a peak height of 30 meters. Okay, so when the golfer hit it, it traveled through the air up to the 30 meter mark and then back down to 0 at 100 meters, 80 meters away. So where it lands is at 180. So therefore, the ball traveled 180 meters. Okay, and that's your answer. Let me know how 8.4 goes. It's pretty straightforward in the sense that you're just identifying things on a graph, and later on, the challenging part is to sketch it algebraically using algebra skills and also creating these graphs as cells. Okay, so let me know how you go, and if you have any questions.